Welcome to Siafunda once more. I want us to look at this subtopics under algebra, which is quadratic form, using a quadratic formula and inequalities. Remember, your standard form becomes vitally important. Your standard form, quadratic standard form, it is ax squared plus bx plus c. You make it equal to 0 if you want to solve for x. Remember, if you look at this one, it is not in that form. It is not in standard form. It is not in the form of ax squared plus bx plus c. So I cannot factorize to help me solve for x in this one. What is it that we're required to do here? We're required to find the value of values of x. But I can't find it if it is not in the standard form. Same thing applies to this one. I can't solve it if it is not in the standard form. On the right-hand side, I must have 0. On the left-hand side, it should be in the form of ax squared plus bx plus c. And this one is not in that form. So is the last one. Let us look at the first one. How can I make this in that form? Here there's a fraction. There's no fraction in the standard form, ax squared plus bx plus c. So the first thing that I need to do here is to get rid of this fraction. At the same time, bring 5 this side so that I will have 0 on the right-hand side. Let's do this thing. Now, how do I get rid of this x here in this term? All that I need to do is to multiply it by x here, so that this x will go with this x. But what I do on this term, I've got to do on the other 2 terms as well. Let's do that. We multiply everything by x in this particular case. When we multiply this by x, what do I have? I've got x squared. When I multiply this term by x, I will have minus 2. When I multiply this by x, I will have 5x. Because I want it in the form of ax squared plus bx plus c. Once I've got ax squared, it should be followed by bx. So I will get bx from this one. So 5 times x, it will be 5x. Take it this side, it will be minus 5x. Then this will be the last one. This times x, it will give me minus 2. Then this side, I will have 0, because this side is already this side, and it's already been multiplied by x. So it is 0. Now, this is the form that I wanted. The form ax squared plus bx plus c equal to 0. Now, I know exactly what is this. When I look at this, I can't find factors of 2 that will give me 5. There are no factors of 2 that will give me 5. Therefore, in this particular case, I will just use the quadratic formula, which says x is equals to minus b plus or minus square root of b squared minus 4ac all over 2a. Make sure that the division does not start here. It starts from there. Everything is over it. Right. Why was it important to put it in standard form? Because I know the value of a here. What is a? A is 1. And I know the value of b here. What is b here? It is minus 5. And I know the value of c. It is not 2, but minus 2. So I'm going to take them out from there and plug it that here in my formula. Let's do this thing. So our x is equals to, remember, this is x squared, x squared, x squared. It means that I'm going to find 2 values of x. I'm going to have 2 solutions here. So my x is equals to minus b. Let me just push in the values. What is b? This is b. So it is minus. You don't forget this minus first. This minus before you write b. So what is our b in this case? It is minus 5. Make b to be negative so that people will make mistake and just write only one negative there. This is plus or minus square root of, what is my b? It is minus 5, all squared minus 4. What is a in this problem? What is a here? It's ax squared plus bx plus c. So the value of a there, it is 1. And the value of c, ax squared plus bx plus c. What is the value of c there? The value of c is minus 2. It is minus 2. Our value of c here, Linus, it is minus 2. Let us divide. Divide by 2 into a. Remember that we said our a was 1. Once we have it in that form, we can just go straight into our calculator. First use plus. After using plus, then you use minus. Or if you like, you can separate it. You can write it in this form. In form of x is equals to minus times minus, it is 5. Then you write plus square root of something over 2. Or x is equals to 5. Then you change the sign. You've used plus there. Now I'm going to use minus. It's minus the same thing, all over 2. Remember, it is exactly like this. It should be exactly like this. Let me just find the value of here and here. In other words, I put this together and find the actual value there. Quickly do it on my calculator. I've got minus 5. There is minus 5 there, all squared, bracket, minus 5, close that to square that, minus 4, bracket 1, bracket, open another one, minus 2, you close that bracket. What do I get there? All that will give me 33. So I know that the value here is 33. Then I work it out. So I go back to my oh, you just do it same time. From the top there, you just do it same time, you change plus and minus. Hence, but we've come to that position. Let's continue with it. So I've got a fraction there. What do I have on my numerator? I've got 5 plus square root of 33, square root of 33. This is divided by, you go down there, divided by 2. What do I have there as my answer? I have, take it there, 5,37. So x this side will be equal to 5,37. So x that side will be 5,37. When I use plus, what happens when I change it to negative? I don't have to do it all over again. I go back to my calculator, go back, delete plus, and push in minus. Once I push in minus, it will be in the position that I have. I press equal sign, that's what I'm getting. I press my SD button, I get minus 0, or x is equals to minus 0,37. So these are the two values of x, because it is x to the power 2. So it tells me that I'm going to get two values of x. So in this particular case, the other one was positive, the other one was negative. So that's how you solve for x using the quadratic formula. Remember, you only use the quadratic formula if you can't find vectors. I didn't find vectors there, hence I used the quadratic formula. Let's move on to this other section called subsection, also called inequalities. That's where instead of equal sign, we push these signs, greater or equal to, less or equal to, instead of equal signs. In other words, you treated this exactly the same way, because there was equal sign here, now there's inequality sign here, which we call them greater or equals to or less or equals to. In this particular case, this times this is greater than 12. Remember, this is algebra, this is quadratics, all about quadratics. In other words, I've got to put it in this form, ax squared plus bx plus c is greater than 0. I must have 0 on the right-hand side. That's the first thing that I need to do here. But to do that, I need to break these brackets first. How do I break these brackets? You go back to your grade 8, grade 9 multiplication. This times that, it is going to give us x squared. You look at this number and this number. 3 and 1, it is, you take the sign of it to find the difference between these two. It is minus 2x, and then this times that, it is minus 3. That's what we have from these brackets. When you say x times x, it will give me this one. Then you look at these two numbers to find the difference between them. It will be minus 2x. Then you multiply these two, it will give us minus 3. Remember, we want to have 0 on this side. We want to have 0 on this side. So you take this 12 that side, it will be minus 12. It is greater than 0. Then you polish it up such that you can see what is A, what is B, and what is C. Let's do it. These are called the like terms. They can be added together. So what we have here, we've got x squared minus 2x minus 3 and minus 12 minus 15. Minus 15, it is positive. Remember, something that is greater than 0 is something that is positive. All right, this is what we have so far. In other words, we are at this stage. Can we find factors here? Can we factorize that? We want factors of 15 that will give us 2. Let's look at 15. If you look at number 15, let's look at factors. We know that it will be 15 times 1. If I add or subtract this, can they give me 2? No, because when I say 15 plus 1, it is 16. 15 minus 1 is 14. So I can't get 2 out of those. Let me look for other factors of 15. It is 5 times 3. These are the other factors of 15. Can I get 2 out of those factors when I add them or subtract them? Remember that I need to get minus 2. How can I get minus 2 out of these two factors of 15? I can only get minus 2 if 5 is negative and 3 is positive. So, or we do have factors. It is minus 5 and 15. So we can factorize this. This is greater than 0. X squared, it is easy to factorize x squared. It is x times x. How can I factorize minus 15 such that I've got minus 2? We said I have to have minus 5 and positive 3. At the same time, when I multiply these two, I must get that term. And when I add these two, I must get the middle term at the same time. Let's check it. Minus 5 times minus 3. Minus 5 times positive 3, it is negative. Negative and positive will always give us negative. At the same time, minus 5 plus 3 gives us this term, which is minus 2. So our factors are correct. We're in the stage of factorization. Remember that when you multiply this and that, if this was an equal sign, when you multiply this and that and it's total 0, it means that one of them must be 0. But in this particular case, we're multiplying two values. This one times that one, we get something that is positive. How do we get positive? We only get positive when you multiply. Remember, if we have positive times positive, it will give us positive. If we've got negative times negative, it will also give us positive. No. So what is this saying to us? What is this saying to us? Remember here, we multiply this times that, we're getting something that is positive. Something that is greater than 0 is something that is positive. If it was this sign, it was going to be negative. Okay, let's move on. This times this is positive. In other words, this value here must be positive, and this one should be positive. If this one is positive, this one must be positive to get positive. Or, if this one is negative, this one also has to be negative, so that when we multiply this value and that value, we get something that is positive, following those rules there. Right, let's move. Let's assume as if this was an equal sign. This is what will give us our boundaries. In other words, we want to find our critical values. We refer to them as the CVs. If you assume this was positive, it was equal sign. So our x was going to be 5, or our x was going to be minus 3. We call these our critical values. These are the values that we're going to plug in our number line. From here, if I'm using the method of a number line, I go straight to my number line. I put the smaller value here and the bigger value there in my critical values. Which one is small there? It is minus 3. A negative number is always smaller than a positive number. So it's 5 there. Let me put my small circles there. Right. Remember here, I've got greater than. What is this I'm looking here? I'm looking for values of x that when I push them in here, they will satisfy this condition. When I put the value of x here and there, it should give me a positive answer. How will I get a positive answer if this is positive and this is positive, or if this is negative and that is negative? Those are the values of x that we're looking for that will be our solution. Let's go. Suppose that our x is minus 3, for example. If in the value of x, I push in minus 3, where there's x, we push in minus 3. We definitely know what will happen on this side. If we push minus 3 here, what is minus 3 plus 3? This will be 0. What is 0 times anything? It is 0. Do we want the solution that will give us 0? No. We want something that will give us something that is greater than 0, not 0. So if you take minus 3 and you push it in there and there, it gives us a solution of what? Of 0. We don't want 0, we want something that is above 0, greater than 0. So this value here, it is not part of my solution. So I cross it out. It is not part of my solution. Then I go and check 5. I'm starting with these two critical values to check if they are part of my solution. The first one, it is not, because when I push in 3 here, if I push in minus 3 here, I will get 0 here. This will be minus 8. 0 times minus 8, it will be 0. Therefore, we don't want that one. We want something that is greater than 0. So this is not part of my solution. We check 5. We check this value here, 5. The critical values first. If you push 5 here, what is 5 minus 0? 0. 0 times anything, it will be 0. So this is also not part of my solution because we want something that is greater than 0. This one, if we push this value here, it gives us 5. It gives us 0. We don't want 0 as a solution. We want something that is positive, greater than 0. Right. If you look at this number line, it has got 3 regions. There's this region, there's this region, there's that region. This one represents all the values of x that are between 5 and minus 3. This one, any value that is less than 3, This other region, values that are above 5. We can check all of them. However, I'm saying to you, you can only just check the middle one, or check one position. Because if this one is the solution, this one will not be the solution, that one will be the solution. If this one, let's work it out so that we'll see. Take any value that represents numbers that are between 5 and minus 3. I will take 0. It is easier to work with 0. If I take 0 to represent all the numbers that are between 5 and minus 3, let's see what will happen. If we push 0 here, what are we left with? If you push 0 here, we've got minus 5 here. If you push 0 here, what will you have this side? Yes, we will have 3. So in other words, this is positive, this is negative, because this is 0 and this is 0. 0 is nothing, something that is not there. So this value here becomes positive 3, this one becomes negative. Let's multiply these two values. If you multiply negative and positive, what do we have? Negative. If you multiply negative and positive, the answer is negative. So if we want something that is positive. So we can see that values that are in between here are not going to give us a solution. You can take any value that is between 5 and minus 3, they are not going to give you a solution. So we used 0 as the one that represents them. So when you push in 0 here, we've got minus 5. Push in 0 here, we've got positive 3. Minus 5 times 3, it gives us minus 15, which is not part of the solution. We want something that is greater than 0. We can't have minus 15 being greater than 0, because negative number is smaller than 0. So these values here are not part of the solution. Now watch here. If this value is not part of the solution, this one will be a part of the solution, and that other one will be part of the solution. Now let's work it out quickly. I'm saying to you, if this is not part of the solution, this will be, this will be. If this is a solution, this will not be a solution, this will be a solution. If this is not a solution, this will be a solution, this will not be a solution. They interchange on these three regions in that way. So we know that if we take a value that is greater than 4, it should give us, greater than 5, it should be part of the solution. Let's quickly check it. A value that is greater than 5, it is 6. Let's push in 6 here. What is 6 minus 5? 6 minus 5, it is 1. 6 plus 3, it is 9. This value is positive, and that value is positive, therefore it will be part of the solution, because we want something that is positive. If you take a value that is less than minus 3, let's take minus 4. If you push in minus 4 here, what will I have? Value that is less than minus 3, it is minus 4. Let's push in minus 4 here. Minus 4 and minus 5, it will give us minus 9. So the value here will be negative. If you push in minus 4 here, minus 4 plus 3, the value will be negative. So you will have negative this side and negative. What is negative times negative? It is positive. So this one will give us a value that is greater than 0, which is part of the solution. Then to write our solution, you write what you see. You write exactly what you see. So what is my solution here? My solution is greater than. It is greater than. Wait, no. Let's look at our solution. Our solution, this is the solution, and that is the solution. Our solution is saying down as 2, so you write 2 of them. This one is less than 3, that one is greater than 5. You write what we see. So our solution in this case, it is less than what? Than minus 3, or our solution, it is greater than 5. So that's how you present this in a number line, and that's how you find our solution. If this is not a solution, if this is a solution, it will be not, this will be.